we're good. I can sense, I can feel the energy just dying in here.
Yeah.
You guys got to keep up the pet for like 2 weeks, man.
No.
Because after 2 weeks, it's just your finals and you're done. So you got to keep that energy up. And then we'll do it all over again, but you'll be rested. But if you just like start to quit right now, you're going to see that take a toll on your grades. So don't do that, okay? And just an FYI, what comes up next semester? Trigonometry.
Yes.
Yeah. Trigonometry. I think you guys will love it. It's amazing. Trigonometry. It's pre-calculus. It's all pre-calculus. But yeah, a lot of it's review. But there's other things that are in there that are kind of setting you up for calc. So some of the ideas that we've talked about will help you there, and then some of the trig was going to help you as well. But we've saved all the trig for a second semester. That's why we kind of went, what was it, 1, 2, 3, 4, 7. Okay, all right, so 8.3, matrix operations. We're operating on matrices, and then if we have time for some of their applications, that'll be great. We'll talk about some matrix notation, which we already did. We'll talk about what it means to be an equal matrix, how to add, subtract them. Pretty simple stuff. You've already done this as well. We'll do a scalar multiplication, which is not the same as multiplying matrices. So please do not confuse a scalar multiplication with a multiplication of matrices. And then we've already did some solving with equations where we did the systems. I kind of showed you how to do it on your calculator because it's going to be much easier to do it with your calculator. If I had the chance, and like on Math Excel it says solve this system, so I'm going with calculator, RREF that bad boy. Okay. So do you guys remember when I gave you an address, if you will, on a matrix? That would be row 2, column 3, right? So they'll do that, depends on the book that you grab, but there's different notations out there as well. Sometimes they'll just give you notation that looks like this right here. So if I'm looking for a specific element, it might say A, 2, 3. That doesn't mean that it's item 23. That would be row 2, column 3. Okay, so don't confuse that with a 23. It's a 2, 3.
Why is it IJ?
I would be for rows, J's would be for columns. So instead of doing RC, which would make sense to me, which was the way I learned it, in this textbook they're going to be using what's called the IJ notation. Okay, so don't let that confuse you. It's still rows, columns, but instead of calling it R's and C's, in this textbook they're going to go with I's and J's.
Is A the answer then?
Huh?
A is what's in row 2, column 3.
Yeah, just the element. The element. Okay, so an array of numbers arranged in rows and columns, placed in brackets. It's called a matrix. You've already seen them before, and they're represented a couple different ways. We can name them. So if I have some matrix with a bunch of values in there, I can give it an actual name. I can say that's matrix A. And I think we've done that with the calculator, right? Oh, I've got matrix A, I've got matrix B in there, matrix C, and so forth. So that's proper notation. So they're referring to that matrix A. Whatever's in matrix A becomes that. That allows us to ask you to do operations on them. So I can ask you to maybe take matrix A and add it to matrix B. So that would be an actual problem. Of course, you'd have to dig out what what the elements of A are and what the elements of B are. Do your thing, and then go from there. Does that make sense? All we're doing right now is talking notation. Questions on notation? Thumbs up, thumbs down. We're good? Not good?
Can you do the bell work, bro?
No, I won't. That was a little trick I was told. Give them the problem. If they care enough, they'll come back. So we'll do it. And just a little hint. I don't know if a hint, but it should be in your notes from yesterday. Well, if you're going to go over it, and I'm not going to do it, then at that point you can't. What's up?
Everything was like here.
We'll get to that. How do we do these?
The A and the B, like how would we put that in the calculator?
Oh, same way that you did last time. Here, we'll see that. But you know, I'm glad you asked that. Sometimes it's going to be more work to do something in the calculator than it is to just do by hand. And I'll tell you why. So, you guys ready to carry on? So let's do this here. All right. Thank you. Here's another notation that you need to know about: the order of the matrix. The order of the matrix. If I have that many items, I've got 3 rows, 3 columns. This is called a 3 by 3. 3 rows by 3 columns. If there was only 2 rows, 3 columns, this would be called a 2 by 3. Questions there?
You're not doing the numbers.
No, I'm not.
You're just stating the
That's okay. We'll come back. I can come back to you. Are we good on the dimensions? That's not a big deal, right? Carry on. And if they are the same, they're called the square matrix because squares have the same dimensions, right?
math like squares.
Yeah, very cool. So what is this guy? What's the order of this bad boy?
2, 3, 2.
No. No, what?
Yeah.
Yeah, it's a 3 by 2. Okay, identify a sub 1, 2.
-3. What?
No, it's -2.
First row,
Oh, -2.
second column. First row, second column, -2. Okay? What's a sub 3, 1? 1. Okay? Be careful there. I've made those mistakes too before. Guys, we're good? Thumbs up, thumbs down? Sideways? Kind of. All right, cool beans. I'll wait for you.
So the order is 3, 3, 2.
The order's the dimensions of it.
So 3 times 2.
In this case, it's a 3 by 2. I want to go. I want to get to the good stuff. All right, so waterfalls. This should not be a surprise to you. If 2 matrices are equal, then the order is the same, and the elements inside are the same. Just like equations, right? 5x equals 10. 5x and 10 have the same value, don't they? Do we know what x is? Should be 2, right? But they should have the same stuff, the same values in there. So let's do some operations here. In this case, they didn't name them, but it's pretty simple. And this is what I was saying. Sometimes it's not worth putting in your calculator because you have to go in there, name it, dimensions, and then put another one, do that, and then go back and calculate. When all I know that I can just go, what's -4 plus 6? -4 plus 6 is a 2. 3 plus a -3 is, it used to be, is 0 now. 7 plus 2.
9.
What's going on?
7, 6, 8, 9.
We're going to scratch this class. We're going to go to algebra 1 now. What's -6 plus -4? And there's your matrix.
Why, sorry.
I had to open the door. It was too hot in here.
They've been attacking me since yesterday.
I'm wearing a thermal under this because I was like so cold this morning.
This morning was amazing. I wish it was like that all day, every day. That is like the temperature.
Just things feel like freezing at times.
You guys good?
I love the soft windows are when I first do it. When you first do it. Yeah, it's like versus when you 7, like you say.
Waterfalls. Cell phones. Go ahead.
So to your answer, on like the homework, would you answer it?
Yes. A matrix. Remember? You Have you guys ever heard of the rule closure?
Yeah, we talked about it.
We talked about closure, right? At the very beginning, no one ever talks about closure anymore. And it just kind of makes sense because closure is saying if you take a real number and you add to it a real number, then you should get a real number. Pretty simple idea, right? You're not going to go real number, I got a jelly sandwich. So, same idea. If I'm taking a matrix and I'm adding to a matrix, then I should get a matrix. Okay?
Like, how do you put a matrix?
It gives us, we just put in the little square.
Yeah, it might give you the brackets and then you put them in, the elements in. Actually, what I've seen, and I remember it very clearly, it'll give you like most of them and you're like, what is this element? And then you plug it in from your solution. Or a couple of them. Does that make sense? You're looking at me like you want more. That's all I got for you. All right, cool. Here, try that. Give you guys a minute. That's too flat. They put the shirt in my box, but it didn't fit.
I'll try it on.
It doesn't fit at all. Maybe my daughter's Barbie. My daughter's Barbie. I have one exactly the same.
It's exactly the same.
Mine's exactly the same. I don't dislike them.
I'm not there yet.
Yeah, bro.
What do you think it's like sitting next to them? Especially if you're
Careful, kids.
I like $100,000
So would I.
Alright.
Just kept on doing it. That was just funny. From the back, it's got kind of all kinds of stuff like
I sacrificed my money for those earrings. Oh, they like Nick. I don't even know. I'm allergic to Nick.
Waterfalls! What size should my solution matrix be? A 3 by 2. What's A11?
9.
What's A1? No, sorry, A22.
-4. Wait.
A22.
7. 7.
Oh, it is a fly.
Can you start writing on the board if it walks? It walks.
It touches this way.
All right, let's just go across. What goes here?
-4.
-4,
Negative 9.
-9, 7,
5.
+5, and -2. Double check your work. Make sure you have it down. We're good? All right, cool beans. Thumbs up if you got it. Slide if you're kind of confused anywhere. You're confused? I can change it? Guys, same thing as when you were learning this in pre-algebra. I can take two matrices, I can add them in any order that I want, right? I can do A plus B, that should be the same thing as. MJ, what should it be the same as? If I want to add two matrices like A plus B, I can also do B plus A because of the commutative property. Same thing goes for my associative. I want to add two matrices. If I got three of them, I can add two and then add the other one. Again, if I have a 0 matrix and I add that to that, then I would just get that matrix back. And then I can add the opposite of a matrix, and that should give me 0, right? So same rules apply. They're just numbers, huh? All right, cool beans. So if A, now they've named them, right? What's the name of this matrix? What's the name of this matrix? Okay, so can you take -6 times B? That's a scalar multiplier. That's a scalar multiplier. You're taking the entire matrix and you're multiplying it by -6. What's our solution matrix going to look like? What's the order? What's the order? 2 by 2. What do we got?
6, 12, negative 48, negative 30.
Beautiful. You Frank?
Hang on,
We're good? Any questions? Put the hair down.
Yeah.
You silly rabbit. Cell phones. Shh. I need my order to come in. Here's what I've done. I've ordered popcorn bags. So that when I see you on your phone, as you're not supposed to be, I'm putting your phone in a popcorn bag and I'm sealing it.
Wait, what is your definition of a popcorn bag? Because that doesn't make any sense. They're gonna.
Little paper bags.
Oh, like brown.
We're really hoping for bags.
So you're gonna staple it all the way around.
Imagine a brown bag, but for popcorn.
Brown bag. Because I was like, I thought it was gonna go into like, we're gonna watch a movie.
Sounds like we're good?
Yes.
Okay. Here we have a bigger operation. I want you to take 3 times A plus 2 times B. 3 times A plus 2 times B. I'll give you 1 minute. I'll do a minute and a half.
he's being generous.
Yes. You don't need the extra half, but.
Yeah, maybe what's up with that? That ones that like you could turn over. I always wanted one of those.
I do, but it's not very bad.
That sounds very short and feminine of you.
Like, I don't care, but like, I don't think my phone would ever be like.
Negative 14, negative 1.
I could never have a pop socket either because like I would just be like pulling it and then pulling it back down.
My wife has one of those where you put it back, and the one that holds the slide, she just likes to jump out and she's like,
Yay, that was good. 4 decisions, 4 decisions. 4 highlighting decisions.
Thanks, they're broken.
We got a circle. We have to try not to
Really kicked it off. Like,
Oh, it's actually a minute and a half.
is my email up?
Was that really a minute and a half?
Actually, it was more than that. Waterfalls! I think about it. It's because I use other words and I'm like, which one is it for this class? Okay, so give me 3 times A. -12, 3, 9, 0. And we're going to add to that 2 times B, which is. And then finally we get our solution, which is.
-14. -1, 25, 10.
Absolutely. Double check your work, please.
I can't take it back now. I highlighted the majority of this. Wow, I like your answers.
Saying that and Kelly's
Okay. So, just like we have the addition rules, we also have the multiplication rules here. Multiplying C and D.
Kick her out.
So again, multiply matrices, you can you can multiply them any order that you want. You should be just fine. Do you guys remember when you multiplied by 1? What was that called? It was the identity property, right? So that still works.
Right there.
In this case, it's a scalar, not scalar.
I said scalar the first time, but no one
Scalar. Distributive property. And then you've got your, well, that's just distributed with the other value on the front. It's the same thing, right? Because multiplication is commutative. Any one of those that I need to explain any further?
That's the one we just did, right?
No, the other ones were all like addition, and these are your multiplication properties. They're all exactly the same but different.
Exactly the same. Exact same one. Exactly the same.
You guys ready for some fun?
Yes.
Because you know it can't be that easy, right?
I was literally like, oh my gosh, sitting up here makes me understand stuff.
That's what I was thinking. Oh, I love your
Waterfalls. Solve for x.
Wait, where is this? Oh, I see.
So here's your equation. You've got 3x plus a equals b, where a is matrix A and b is matrix B.
So you just subtract it and divide it. Oh. So she got there so good.
I guess in the front is helping, isn't it?
We're all just gonna be like cluttered in the front fighting over the spot. Sit right there.
I'm just gonna sit on the wall.
You should do a carpet.
I am
where
the
you
star
sit on
one.
the floor. Like, so, yeah. Like when they.
Yeah, that's not a bad idea. Like in my preschool class.
Yeah. Like carpet time.
Carpet time.
Carpet time. That's the whole class period.
I don't know if the maintenance guy would vacuum my carpet every day.
Oh my gosh, it's like directly on the face. They like got me too.
Mine.
Okay, self-right. Oh wait, we're supposed to actually do it. We're just talking real.
Oh, yeah, you're right. Bro. Oh, wait, no, that's shit, I gotta mix it up. And that's 13, right?
sense that it should. Don't look up here. I just need to write.
I feel like this is correct, but I'm not sure. It's okay. No.
That's what you did, right?
What? That's not what I did. Felix Wait, can you just subtract the matrix first?
Yeah. I'm just looking at something. That's why I said don't look up here. I want to see what she did.
Okay, my voice is so annoying.
That's what you did, right?
Well, first I moved the 8 to the right side, and then I divided it.
Okay. All right. Let's see if it happened, okay?
Oh no, I forgot to divide the other side.
The other side by 3. Okay. So to do this, don't plug matrices in first. That's going to make it a little bit tougher to manipulate. Solve that original equation for x alone. So if you've got 3x, that's going to equal b minus a, correct?
Yep.
Multiply this whole side by a third, or divide by 3. Same idea. That will make this a 1, and you'll get x. But you'll have to multiply the other side by a third as well. So now, what I've got here is the difference of two matrices, and then a scalar multiplier. So x is 1/3. Let's do b minus a. Negative 10 minus 2. Negative 12. 1 minus a negative 8. Negative 9 minus 0. Negative 9. And then 17 minus 4. 13. And then I can divide everything by 3. So negative 4. Negative 3. What the heck is this?
1/3, I believe.
13 thirds. There you go.
Exactly what I got.
Thumbs up, thumbs down.
I'm wet.
Good. Good.
I can do it
Oh, we got the good stuff now.
That was not fun.
Okay, so I just want to, waterfalls. I just want to repeat this. I feel like I got this fixed here. This was scalar multiplication. This we can do, right? Multiply two matrices has its own rules. Very different, not the same. Okay. Let's go ahead and go back to. Let's go ahead and go to the next one. So now we're going to multiply matrices. And here's what the definition looks like. If you're going to multiply a 2x2 matrix, okay, you're going to take. No. Don't write it down because it's not English. Like I said, I'll translate this into English for you, okay? And then I'm going to show you. Yeah, you're welcome to take the picture. And then I'm going to show you a nicer way of doing it, like something that I just researched for you guys alone. So I have never taught this method to anybody. You guys will be the first. And if you like it, good. If you don't, then do your own research and find another method. Okay? Now.
So it's like distributed property.
Yeah, kind of. Let me tell you what the rule is for multiplying matrices. If I'm going to multiply two matrices, let me do. Are you guys okay if I use this notation? The rows of the first matrix, columns of the first matrix. I don't know if that really is notation, but I think it'll make sense. So I have this matrix, and it's got a certain number of rows, and it's got a certain number of columns, right? Then I have a second matrix. It has a certain number of rows by a certain number of columns. Okay? So in this case, I have two different matrices. Here's what you need to check. You need to put the orders side by side and check that the columns of the first match with the rows of the second. And I'll tell you what that means. I'll show you mathematically in a little bit, okay? So you can see what's going on. So you're going to check those two inside ones, make sure that they're the same. And if they are, then you can multiply them. If they're not the same, they cannot be multiplied. Now, if you can multiply them, then the order of the answer will be these two dimensions. Let me tell you what I mean by that, okay? You guys ready?
Sure.
I have a 2 by 3 and a 4 by 2. We understand this, right? Because now it's more concrete.
Oh.
Okay? So, do my two inside, does the columns of this one match the rows of that one?
No.
They do not. Therefore, I cannot multiply these two matrices. Cannot be done. So if you get something like that and they say multiply the two if possible, then at that one you will say,
Not possible.
this one that's not possible because the rows of one do not match the columns of the other. Now, be careful here because this is a 2 by 3 with a 4 by 2, right? What if I told you I want you to multiply that 4 by 2 by the 2 by 3? Oh! Yes, you can. Yes, you can because the columns of this one matches the rows of the other. And my resulting matrix would be a 4 by 3. So that I know that when I do get answers, I'm going to have 1, 2, 3, 4
So there's
rows
multiplicative inverse for
and 3 columns.
Wait. So is there no multiplicative inverse for matrices?
Yes, there is. There is a multiplicative inverse, so we're going to do that later on. You're welcome.
Well, we can do this. in
It's
calculus.
fun, that's why. Okay, I want to make sure that we understand this.
Kind of.
Let me do another one real quick here. Can I take a 2 by 4 and multiply it by a 3 by 6? Cannot be done. Can I multiply a 2 by 3 by a 3 by 4?
Yes.
Yes. What would the resulting matrix look like? What would be the order of it? It would be a 2 by 4. Let's do this again. Can I take a 2 by 2, multiply it by a 3 by 3? Why not?
The rows and the columns are not.
The two inside ones don't match, right? What if I did the 3 by 3 with a 2 by 2? Still can't be done. What if I did a 2 by 4 with a 4 by whatever, right? Yes. And the resulting matrix would be a 2 by what?
2 by 3.
Oh, no, I put a number there, yes. A 2 by 3. Guys ready?
Yeah.
Now, this is the way they want you to do it.
Hold on.
It doesn't look that hard though. It's just A, B, C, D, A, B,
Because it's a 2 by 2, my dear. So it's not really that hard. It really isn't. Okay? But I'm going to show you through my extensive research what I found.
Oh no, it wasn't.
For starters, can this be multiplied?
Yes.
It can? How do you know? What? No.
Yes.
Yes? It's a 2 by 2 and a 2 by 2, right? So I can take that 1, 2, 3, 5, and I can multiply by my 2 by 2. What's my resulting matrix going to look like? 2 by 2. Okay. Let me show you how I want you to multiply these. Put your pencils down. Oh, you're going to write that down real quick? Because I want you to watch what I'm going to do first. Here's matrix A. And then remember, it is A by B, correct? So here's A, and I want you to put matrix B in this position here. 4, 6, 1, 0.
It's 7, 6.
Okay? So it's kind of offset that way. Because here, I'm going to write my answer matrix. And it's going to be a 2 by 2, correct? You guys ready? Here's the way it goes. I'm going to take my first row and multiply them by the first column. And it goes like this. What's 1 times 4? 4. And then I'm going to switch to the next two. What's 3 times 1?
3 times 1 is
3. So what is the sum of those two? That goes here.
Oh. Okay. He's only doing the first one too.
Okay.
I know.
Let's do this again. Now, what's kind of cool about this is I can do any one I want in any order. Which one do you guys want to do? Do you guys just want to go across?
Yeah.
Okay, so let's do this spot here. That is in the first row and in the second column. What's 1 times 6? 6 plus, what's 3 times 0? So that's going to give me 6.
I'm gonna need more calculators.
Okay? Let's do this one now. This element is in row 2, column 1, row 2, column 1, 2 times 4, 8, plus 1 times 5, that gives me 13. Give me the last element, please.
Row 2, column 12, yeah.
It's just 12. Good.
Wait, actually, don't.
Oh, you put them in the calculator, most likely?
Are you smelling Parker? Oh, Parker. I was like,
No, I was puckering my lips for it to keep on.
yeah.
So my wife got this for me at Ulta, and I'm like, being the guy that I am, I'm like, $10. I'm gonna get a chapstick for 2. And she's like, no, chapstick has alcohol in it.
Not too bad.
Chapstick has alcohol in it. That's why you always feel the need to keep putting it on and on and on, because alcohol will dry your lips. And I'm like, okay.
Oh, that is just because like your gut, you get like a big tattoo.
No.
Like your body's like
Chapstick has alcohol in it, which dries your lips, which makes you feel like you need more, and you keep applying it so you can keep buying more. And then on top of it, it's not good for you. And she got me this, and it feels cool. I didn't want to feel it feels cool. But it has a grapefruit scent, and it has an SPF of 25.
Unboxing. I know.
Jack Black and Ulta. Get yours now. Waterfalls. We're not done with this one?
I have like 3 pictures there, man. That sounds weird. Wait, so wait. Okay. Oh, wow, weird. Okay. 4 plus 3. I'm thinking about on the colored markers. 6 plus 8. Okay, wait. Can you do it again? Okay, this is kind of making sense.
Somebody unfreeze. Okay, so check this out. Let's do this one. Let's do this one.
That's a 2 by 4.
This is a 2 by 4
2 by 2.
with a 2 by 2. Right? No. I'm asking you to do this.
No, we know. We already did.
Can I do this? No, this cannot be done. Raul, why? The only one up there.
What action are you talking about? I wasn't honestly looking right now.
I know, that's why I
In
called
that
you.
very moment.
Can we multiply? They said we can't multiply these, and the question was, why can't they be multiplied?
Because
Okay, so it says that one's a 2 by 2, that one's a 2 by 4. Alright? No.
Yeah, that's what we wrote.
You know what I'm saying? Like
Flip it and then be like,
Because the two inside don't match. Can't be done.
but can't you multiplicative?
Here's what would happen. Check it out. Let's go and do that real quick.
is that how this?
Let's do this real quick. So let's start putting our answers in, right? What's 2 times 1? What are you doing today? 2 times 1 is 2 plus, plus 3 times 0, which is plus, whoa. I ran out of numbers. You see why I can't do this? What's up?
It was a 2 by 4 and a 2 by 2.
Right.
So why couldn't you switch them and be a 2 by 2?
I could switch them, but can I do this problem that I asked for? No. But if I did switch them, could I do that?
Yes.
Yes. You see that? So let's do that. Go ahead and do that real quick.
I did it.
I'll let you do this one. Can this one be done?
Yeah.
What's your resulting matrix going to look like?
2 by 4.
2 by 4.
2 by 4.
Okay, this makes sense. Because
But I'm so
so whatever row or in column it is, then you have to like,
I'm coming.
so like this is row 1, column 1, so then you multiply row 1, column 1. Get this, and then you add like no, 1 by 4 and 3 by 1. That's why it's 3 by 4. And it's row 1, column 1, which is what this is. Oh, wow.
It's not 8 times 3, it's 7 times 8. Just remember it doesn't work, so we say that and that'll be my background.
No, I need to see if we can erase it.
Congratulations.
Okay.
this makes sense to my guys. It makes the same. It's because we send them right now.
Oh my God, no!
Yeah, the pen will be closer.
Yeah, guys, how about like over here? Maybe it's not.
I had such a headache yesterday from the freaking order my face. Makes you feel sorry for it.
Like this, right?
You know what? Never mind. People try to put that in. Please make sure that you do the exit ticket.
Hey, since we're done, you go over the bell word.
Wait, how did you do that? Because you had to like. I got 2 right. So I mean, how would you do row column 3?
So, this one, which one do you want to do?
Like I just gonna do like the first 2 columns and rows. I mean first 2 columns, but then you get
Which one are you trying to do? Give me the address.
column 3, row 1.
Row 1, column 3. This one here?
Yeah.
Okay, so that is row 1, column 3. -1 times -1 is a -1, plus 3 times 4
That's
is
why the
12.
rows don't work if they're too many, right?
That's why you got to make sure that your columns from the first one matches the rows from the second, because that's how we're multiplying it out. We're always multiplying rows by the columns of the other.
Oh, got you. So wait, what would it look like if it was wrong? If it was wrong.
Remember
Why
how
do
we
you, like,
remember how we
set
ran
up
out of numbers? Like we were able to do this one with this one, and this one with this one, but then I didn't have anything to multiply -1 by. Like, see how I ran out of numbers going down? I needed 2 more, didn't I?
Oh, okay, got you.
That's why it should have been a 2 by 4 with a 4 by 2.
Okay. It makes sense. It makes so sense. Wait, Mr. Munoz.
What's up?
This is okay. So I have to like work that the statistics dude did, and he was like showing me like inverse and stuff.
For matrices?
Yeah, like
We'll be
A
doing those.
-1.
We'll do those later.
So new to me.
What's up?
How many tests can we
What?
Yes.
Like how many tattoos you can get in a day?
No, tests can we read?
Where'd you get tattoos, bro? You can
Probably 2 at most, because you get 1 hour for each. And if you stay for both hours of tutoring, then you got 2 tests.